right, welcome everybody. So this is IETF 93 diametry extensions working group. So familiarize yourself with the node well. And yes, the first thing, so we need a couple of Gene, you would, thank you.
In the Java room, there's just Echo and one other person.
Stephen.
Hmm?
Stephen.
Okay.
Yeah. And then we have blue sheets. All right. So are you, Gene, also in Java? Are you also in it? Okay. Excellent. Right. So actually, our agenda today is not that heavy. So we have a couple of presentation mainly from Steve. I will be covering the DOIC status, and then we have one more kind of late addition to the agenda, which will be on the group signaling, and then Marco is going to give that. So for the document status, so we have now a bunch of new working group documents, as you know, the agent overload, doing well in a working group, also rate control in a working group document, and then this load document. We still have the group signaling entertaining us, I don't know for how long, and then the also the end security requirements document. So that is got recently revised, addressing the comments from Steve, so thank you. And it's in the stage that it's waiting for the proto write-up and then to be submitted to the ISG. Also the congestion flow attributes, that is in a AD follow-up state, unless there has been a change in recent days. 406 provisioning is now in the IETF last call. I recently did the expert review for the IANA, and that's done. That led to one change in the document, but it's in doing good progress. And I'll go then through the DOIC on the when it's time for it. Right.
Just Steve Donovan, quick point on the agent overload and rate control. I'd just like to solicit comments on it.
Okay.
It's not on the agenda because there have been no changes since the last meeting, but we need review of those documents so that they can move forward. I mean, I'd like to think I got it 100% right in the way I wrote it, but I suspect not. So.
All right. So yeah, we will remind that also on the mailings, encouraging people, also those our numerous supporters outside IETF that have been very active. So let's hope to engage those people again. What else? You got anything? All right. I think we are ready to start with the working group draft discussions. So the load information conveyance, and then the after that the DOIC status. So Steve, you basically have as much, you can take as much time as you need.
Okay, so this is on.
It is on. We just need to fix the closure.
Just closer. Okay. So the load document is replaced what was the load considerations document from the last meeting. It's fairly incomplete yet. It's a first step in definition of the load mechanism. Next slide. So it will eventually define the mechanism. Right now it's mostly front matter, waiting to resolve the issue that we'll talk about today, hopefully. Next slide. So I believe we have consensus on supporting a peer-to-peer mechanism for load, where diameter server would communicate its load to its peer, be it an agent or a client. If there are multiple agents in the chain, an agent would do the same, or an agent could do that to the client as well. So that aspect of it, I think we have consensus. I haven't heard anybody pushing back on that for quite a while. The AVP definition for this is TBD. I wanted to wait until we have a resolution on the sender or the server load concept before we defined AVPs, but I do have some slides in here that give a high-level suggestion of what it might look like when we get to that point. One thing that is different between load and overload, because we can have a mixed network of elements supporting load, some supporting load, some not. The proposal is to support including the diameter ID of the sender of the load report in the load report itself, and then the receiver of that load report can determine whether it really is its peer or not. And if it's not its peer, then that load report presumably transited through a non-supporting agent, and that receiver of the load report can ignore it, or should ignore it, because it's not applying to its peer. The proposal is the frequency of sending load information is an implementation decision. The element who is sending load information is giving a suggestion to its peer on how much traffic or how busy it is, how important that element that is sending it considers that load information, whether it sends it with never request, whether it sends it when the load information changes by some amount, or sends it periodically every 10 seconds, every second, whatever that might be. We might have some wording on the impacts of different strategies in the draft, but it would be left as an implementation decision of how frequently to send. Receiving node, again, verifies that it really does apply to the peer, and if it does so, saves that information for its handling of subsequent request information. And again, a lot of how it does that load balancing, how it uses that information will be implementation specific, but probably some suggestions in the draft on how it would be expected to be used. An input into a routing table with some kind of balance, some kind of weighting on each of the peers that can receive a request, and use that then as a load distribution, as part of a load distribution algorithm. Okay, next slide. So the open question is whether we also support the concept of server load. And more accurately, I should say endpoint load, because obviously requests can go one way or the other, but in general, it's probably going to be servers where this is more important. Most of the requests going in the other direction are targeted to an individual element, and there's not a lot of balancing that can be done. I assert that this is required to be supported, or is a use case that should be supported, because there are deployments in the world today. I can name greater than 3. I won't name them for confidentiality reasons, but I can name greater than 3. There are probably, I suspect that there are greater than that. I mean, it's often on a size of network consideration where it's a consideration. Go ahead, Martin.
Martin Dolly. Yes, this is something that we believe needs to be supported, due to our network deployment.
Right. I couldn't say that, but you could. Yeah, specifically. So there are cases where very large diameter networks are partitioned, for instance, where a set of HSSs are handling a subset of the users. It could be a case where on the policy side of the world where it's partitioned based on geography possibly. There are other cases where it may not be a partition network, but there is a node other than the previous hop to the server that is doing server selection. So it could be that even a client has a list of potential servers, and its responsibility is to choose which server it sends to rather than the previous hop. Now, there's been some discussion on whether this is consistent with the diameter base spec, and I don't think that there's a lot of value in arguing that. I think, in my view, the base spec is inconsistent in whether or not more than realm can be used by somebody other than the previous hop for routing purposes. I think if you read parts of the spec, it's pretty clear that that cannot be handled. In some parts, it implies that it can. That's just kind of of where the draft is. What I'd like to propose is that because we have real-world needs for this, that we in the load draft itself, we could separate this out if we felt like we needed to have a BIS on the base spec. I think that's probably not necessary. What I would suggest is that we have a section in the load draft that talks about the specific scenario where we have nodes that are not adjacent to the servers doing server selection, and in order to do that, need to have load information to properly do that server selection. And if they, and then we define a set of AVPs to allow that server load information to transit end to end rather than peer to peer, like we talked about in the previous version. And then any node in that transaction, or any node that receives that information, then can use it as to select a route. And presumably would include the diameter or identity of the node to which that it wants to be routed, and with the expectation that next hops would honor that information to route the request to the appropriate node. So that's the proposal. I guess I would ask if there are any objections, and Lionel, I know you'd had some opinions on this. I don't know if you.
Yeah. I think it may be so. For instance, we have the case where in your proposal, so initial proposal, it was based on the fact that the presence of the destination host in the request may impact the routing decision.
Correct.
That is not so clear, but I think it is something that could be indicated in a separate section, saying that when you are using this. Mm-hmm. Because actually it would mean that it could be application specific, for instance, or in a specific context. It doesn't apply that any node diameter. The problem is that if any node in the middle doesn't support a basic stuff, doesn't support this, it may not work.
It may not work, right?
So I think that putting some information saying that if you are relying on this information to decide which diameter path to use,
right,
this is something that can be used.
Right.
After that, the open discussion was that is it something that need to be put in this document, or could be put only where it is used?
You're saying in,
for instance, in a 3GPP spec or whatever, is it
right,
something that need to be standardized? It's something not so relevant at this time because we can decide if we need this after that. But I think that having information saying that if you are using this for any purposes that is not strictly diameter based related, I think it's something valuable to indicate in the draft.
But I also think that for implementation efficiencies, specifying the format of the AVPs, that if an application does decide to incorporate this server load concept, that we would define in this draft the AVPs it would use to do so. rather than having a different set of AVPs defined for server load in CX versus SH versus GX. Same reason we did for base diameter.
No,
and
no,
load,
for
right?
sure. But just for my recollection, is it something that will be based on a kind of a new type of load information, or it will be a different AVP?
That's for us to decide. I mean,
Okay.
I've got a
my assumption
I've
was
got a
that.
suggestion or a slide on that.
Okay.
Up. Yeah.
Can discuss.
Okay.
Yeah. Roland Jetzke, Deutsche Telekom. I was a little bit puzzled about the discussion. Of course, we support the work here with regard to the overload stuff. With regard to hints how to implement the overload mechanisms, I assume that you give some hints how AVPs could be used.
Yeah.
Or
Yeah.
do I have a different understanding that we need some, let's say, framework within 3GPP or IETF where it says, okay, you have now this AVP and now what we can do with this AVP?
Yeah, and just to be clear, you said overload. We're talking about load here.
Yes, load.
Okay, good.
Load.
Yeah. I just want to make sure we're clear.
I'm only looking, load. The dangerous thing is overload, but of course, load is the important information you have to need. Right.
And I think we would have guidelines on how you might want to use this or how you might use this information. It just would not have prescriptive must-do level requirements in the document that in how you would use load to do load balancing.
Okay, that satisfies me. Thank you.
So next slide. So on the AVP design, I mean, this is a fairly simple, fairly straightforward mechanism since we don't have a negotiation mechanism. It's someone who is sending load sends it no matter what, and then somebody who can receive it processes it. It's a hint, there's no prescriptive behavior tied to it. So it's so we decided earlier not to have a capability negotiation like we have with overload. If we run into things that make it look like we need it, then we can obviously change that decision. So it looks something like this, where you have a grouped AVP called maybe load, or we can come up with other names if we want to, that has a value and the identity of the node itself. Now, we potentially could also add a sequence number if we felt that was important as well, and to handle the case where requests or where load reports come in out of sequence, just to make sure you're not getting the wrong information. I don't know that that's needed, but that we can, if there are opinions on that, then love to hear it.
Okay, so unlike overload, where something was needed.
Yes.
I don't think we need it here because, I mean, the nature of load is you're going to use the load information to load balance to avoid overload.
Right.
And so there's room for a little bit of error there, right, if you're off a little bit, versus if you're already in overload, considering the nature of, surges and spikes,
right,
being a little off could mean you're killing the network.
Could be, yeah.
And so I think that would probably be overkill, and keeping it simpler for the load without a sequence would probably be a better design.
And that was my thought exactly. Yeah.
Yeah, and same feeling for me.
Buying to Dagesh Nokia. Just one question: that how would you like to handle the restart scenarios on the client side?
Handle
restart scenarios when your client restarts and won't have any load information from the server.
When it starts, it figures the load is it probably, and this is pretty much an implementation decision, but a restart would wipe out previous load information. It would start with assuming that everything is unloaded until it gets its first load report from that.
Okay.
Yeah. Yeah.
I think it is something that, sorry.
Go ahead.
Yeah, I think it is something that need to be clarified. It is not, because it is assumed that the the client or the node sending request is able to rely on dynamic information on information received from the network to perform dynamic balancing, load balancing. So from the beginning, you may assume that any destination or any peers will have the same repartition, and it will react according to information received from the network, if any.
Yeah, and there's
and if he's able to react on this one, because the de facto situation would be that he's not able to do that.
Right. Yeah, and then there's no implied requirement to persist the load information across a restart. Yeah. Okay, next slide. Okay, so this is where the server load concept comes in. If we support it, I would envision as something like, I don't have the text on the slide, but the way that it would operate would be something like servers would still just generate a single load report. And then if there is an agent there, it would propagate that load report, maybe modify it to be a server load report, and then generate a load report for itself as well. Or the other way to do it is that the server generates two load reports that have the same information, just two different types. We could do it either way. If we want to make it easier on the endpoints, then we could certainly have the agents that know there is a need for propagation of that server report generate the server report or the endpoint report at that point. Because there are networks where that would never be used. If you have a client talking directly to a server without an agent there, the server is generating two reports with the same information for no reason. So that's one approach to do it. We could do it either way. As far as AVPs are concerned, two options. One, we have a load type AVP as part of the grouped load AVP, which indicates whether it's a peer report or an endpoint report. Or we could have a completely separate set of AVPs, a new grouped AVP called something like servers load or endpoint load that has the same information in it, the same two sub-AVPs in it that we talked about earlier.
I have one question. Just one second.
Perhaps on these two possibilities, I would have a trend towards the second one, so a new grouped AVP, and maybe for two reasons. First, in some networks, they may only use the peer selection, so they may decide not to use a server selection. So for them, it would be the load. They don't need to look at the load type. It's always peer. The second point is that if when a diameter node will look at the server load only if it is a node that may need to lose the server load. So, and a node that doesn't have to do server selection, it has not to address this group AVP.
Right, very good point.
Yeah, Roland Jeske, Deutsche Telekom. Looking on these sentences and looking on your approach to have a very easy AVP, how this will fit together. On one side, you're asking for, let's say, indicating a server some load in addition, when I understand it correctly, how you will mark the AVPs from the source, at least.
Yeah, well, that's the question, is whether. So we have. Sorry, random thought. That might modify this a little bit. We'll have the peer AVP that has the source, the diameter ID in it. Is one enough? Is the question that's coming into my head. You know, if we pass that through, well, but you still need to understand if there are multiple agents. You have that report coming from the agent that is the peer, and you have that report coming from the endpoint. You need to have a way of differentiating those two, and maybe that's the point you're making. One way to do that is to include a load type sub AVP, and just indicate that this is either a type of peer or a type of endpoint. The other way to do it is a new grouped AVP. Have two grouped AVPs, one called peer load and the other called server load or endpoint load.
Yeah, I'm only remembering the last meeting, the complicated network pictures you had with regard to passing a couple of servers which are proxying at least the AVPs. And I know that we have in SIP the history info header, like something like that, which is a very complicated mechanism. The problem is I don't want to have it overcomplicated, that stuff of load. With regard to indicating how I should decide on routing mechanisms. That's my point, what I would like to make. It should be an easy mechanism to decide which route should I take, which DIME agent should I take towards the destination.
And this is as far as choosing the next hop. This is just giving you additional information that you can use to choose that next hop. It can either be information based on the host, or based on the peer, or it can be if that node is doing server selection, it can be information based on the server load. Yes, but I think it should be very straight. Whichever way we go, it should be very straightforward. Nothing anywhere close to SIP history. That was very complicated. Yes.
Yes. I had one question. Is that for the second one, or even the second type, whatever the final format that we will select for the AVP, but for the server load case, do we need to have something else than because it will not be from a peer, it will be from a node that is not a peer, so you have multiple, so you don't know exactly when you will receive this information and how you will be refreshed. So you may assume that this server will, this proxy will be in the path of any request and so on, but actually it will depend on the implementation that you will have. So I was wondering if we need to have something about the freshness of information received. That is not the same for the peer, because with the peer you have a direct connection, so you will receive always something.
Yeah, that's a good point. Are you thinking that it'd be in the AVP? Oh, so a timestamp or something in the AVP, or to indicate how old it is?
At least it was an open question to consider, because we had this discussion also last time, and to ensure that the information will be taken into account, but for so it could be implementation specific anyway.
Sure.
But you may assume that it's not the same level as a information as an information received from a peer, because from the peer you will always exchange something, or the connection is closed. From a server, you don't know when you will receive a new information. So.
Yeah, that's a good point. I mean, statistically, you're probably going to get it in a large-scale network, but not all networks are going to be like that. So that's a good point.
At least we need to have some indication about that, if we talk about that, even if it is implementation specific.
Yeah, so the frequency of sending might be different on this type of report then, and that might suggest that this endpoint itself generates the report. I don't know, we'll have to think about that also, as opposed to the agent in front of the endpoint.
Yeah, okay.
Yeah. That's a good point. Okay, next slide. There are some security considerations that we need to think about. This is this load mechanism, if you're thinking about a way of using it nefariously, and if you wanted for some reason to take all of the traffic yourself, or try to influence things to get more traffic sent to you. If your server is getting paid on a per transaction basis and your competitor server is getting paid on a per transaction basis, you might want to use this as a way of getting more traffic sent to you. Or you conceivably could use it to cause all the traffic to be sent, or more traffic to be sent to your competitor's server as a way of making it look bad or something. I mean, these are kind of strange scenarios to talk about, but something to consider. And then there's also a consideration that these load reports could be used to infer network topology information. So it's probably something that you don't want to transit domain boundaries. So no answers to what to do about these, but just something that we need to be thinking about as we progress the draft. And if people think of other security considerations that need to be factored into the design of the draft, please put them on the list. We need to get the list activity going a little higher here. Next slide. Okay, so do we have a decision on the server load or the endpoint load? separate section talking about if you're in a scenario where this is needed, this structure of AVP would be used. So some other considerations maybe about frequency of sending this endpoint information, whether it's sent by the server itself or the agent in front of the server. All that would be in that separate section. We'd have a section on peer, a section on endpoint. Everybody okay with that?
Yeah, my recommendation would be to be careful about the wording that we will use about the use of any destination host in a request. So to say that it is what it is from my point of view. So I will not reopen the debate now, but what it is assumed is that you may have additional routing criteria defined per application.
Right.
So my assumption is that if we are generic enough to say that the presence of the destination host could be used for any other could be used for route decision for a specific application, for instance, we are generic enough to say that okay, you may use it, but you can expect that not all the nodes, the diameter node in the signaling path will be able to do that. And I think that from the standard point of view, it's okay.
Okay, that's
After that, if for instance 3GPP wants to rely always on this way to decide between two different passes, I think it's a 3GPP decision, but at least we have an indication on how to provide this information.
Applications in general, yeah. I think it's really more about if you have the need to insert destination host into the request, you can use this information to determine what destination host to insert into the request. Obviously, in most cases, you're probably doing it to influence routing by subsequent nodes, but you're just inserting it, and how it's used later is up to the application, right?
And my point was this one is that in some implementation we are relying on the fact that the destination host is present to be able to decide between two different routes, right?
Correct.
But it's not even relevant. I think it's because you may have some implementation in the proxy, for instance, using the load information just to select two different peers, even if the load is not. It's not even the server load information itself, and there is no server selection. But this information could be used anyway to select a peer.
Yes. So I think we're saying the same thing. You'll make sure that I get the text right, I'm sure.
Okay.
Yeah, good. Okay, so the next step then is to flesh out the mechanism parts of the draft. That should be pretty straightforward to do. Work with Jean-Jacques on that to get it ready, hopefully by Yokohama. I would be surprised if we didn't have it by Yokohama. Okay, and that's it.
And of course, you need, as you said, for this one and for any other document, we need review, comments, involvement. I think it is a general comment for all the documents. So we said that at the last meeting. We need to have people involved in order to progress the work, because you can see that now from the IESG we have feedback to say that we need to have a discussion and so on, and to ensure that to ensure that the product, the output of the working group is a fair product, and so we need a contribution.
Maybe not as much as we had on DOIC, but
yeah,
but some.
But at least DOIC was a good thing in this point. Maybe too many mails, maybe too many discussion, but at least it was active, and you can remember that what we had at the end of the document is not what we had at the beginning of the document. So it was something.
Yeah, it worked well.
Yeah, especially for you. For your workload.
Yeah, well, for our workload, yes.
Thank you. So. Next step, no, it was the last one. So after that, it's DOIC, so it's for you.
Yeah, you can be somewhere around. So. Okay. Anyway, so for the DOIC, I don't have any slide waste for that, but a couple of things. So the document itself is now in IETF last call, so there was a 1 week kind of sanity period before that, which was caused by the unusual situation that the knowledgeable gracious co-chairs were both on that document. So The AD, Stephen, and a couple of other guys just wanted to make sure that there are no issues about that, and the process had been done in a proper way. And as we did also, is that we could show that the whole process has been documented, which is okay. Actually, so in a sense that we started using issue tracker from the beginning, and everything can be traced down to the consensus process, and the actual discussion has been massive, which was positive. So there's no concerns on that side. So, but there was this 1 week period just to make sure that everybody's happy about that. So the early INR allocations have been done, so all the code points are there. So the next thing is that we'll actually, once the IETF last call ends, there might be some comments that need to be reflected. And
Steve Donovan, on that point, I know Stephen had given some input prior to the IETF last call that we need to comment on. And I'll take care of that after IETF last call finishes. If we get anything else, obviously we'll reflect that. And there were a couple of comments that came between meetings that might require some tweaks in the document.
Are you referring to the comments from Ulrich, or?
Probably. I don't remember.
I think that we went through those yesterday with Lionel, and I think that we came to conclusion that we don't need to reflect those.
So there are no text changes in the document? Okay. Okay.
So
I don't know if there will be from Stephen's comments or not.
Yeah.
But
anyway, if there is a real concern about the current text, and a need for improvement, this needs to be done now during the IETF last call. It cannot be done after that, because after the final, so the end of the period of the last call, we can modify the document, but only for editorial stuff and so on. But it will be ready for publication after that. So if there is some need to even to discuss a point, not to reopen something, but if there is a proposal to clarify something and so on, you can discuss this with Ulrich, for instance, or any other people are raising comments. And if it is something important enough to take into account during this, it should be discussed on a main list. Because anyone, it's not about only IESG review, it's anyone having a problem with the document can raise any comment. So if it is something to take into account, we can use this period also to modify the document. If it is not so important to reinitiate the last call, it will be handled in this period. Yeah, so please discuss if you have received a comment, and for this one with Ulrich, you can discuss with the author of the comments and see if there is something to do during this period, not after.
But one thing that I would like to bring up, that avoid kind of opening, even if we had some issues that required a lot of discussion. So I would encourage not to reopen those that we reached consensus, even if that was rough. Yeah. So, but if there are issues like problems and non-working stuff, those of course need to be addressed. Right. So yeah. So after all, the document is in a fine process. So I would assume that if everything goes okay, we will have a RFC number in 2 months, basically. All right. Next is Steve again. So this is the okay.
Okay, this next discussion is on diameter routing message priority. I had presented in Dallas a proposal that we define a generic message priority marking mechanism. Next slide. That slide still says Dallas. I guess I didn't update it. Yeah.
You have time. So.
You want me to update it and resend it to you so I can. Okay, so the basic problem statement is there's currently no mechanism to for a diameter node to treat requests any differently based on the context of the request. If it gets an overload report and needs to throttle, right now all requests are created equal by definition. And there are scenarios, emergency responder type scenarios, natural disaster type scenarios, where there may be the desire to have certain requests given higher priority or decrease the probability that they will be hit by throttling in some of these unusual scenarios. So next slide. So these are some of the use cases that in discussions I had with various people were brought forward. The first responder emergency call related. There may be differentiated services cases where you give a better, you promise better service to one customer over another, and you could use this to implement that potentially. And then also there are application-specific priorities potentially where for the same request, you might want that request handled differently based on the context that request is happening. Where for the example that was given to me was the ULR request in the S6A application. I'd be given a higher priority for MME restoration than for initial attaches.
Yeah, and actually another example would be for government priority services as well as for the first responders, where they're using the HPA, the high priority access capability. And so you're making excruciating pain in order to get high priority access from the UE to the EDNOB, to the MME. If you don't have the same level of priority, then getting from the MME to the HSS and then so on and so on.
It doesn't help.
Yeah, it doesn't help.
Yeah. Breaks down all the good work done in the earlier parts of the process, yeah. Okay, so next slide. So I refreshed the draft. It's now as a 01, and it actually contains a fairly complete proposal for mechanism. It's pretty straightforward. It defines an AVP for carrying transaction priority. We had talked about whether it should apply to a transaction or a message. We decided as a group in this room in Dallas, this kind of same type of room in Dallas at least, that transaction made the most sense. So the same priority would apply to requests and answers. Obviously, that was early discussion. So if we want to change that decision, we certainly can. We decided to go with 5 priorities levels, one set of priorities with 5 priority levels defined, 0 being lowest, 4 being highest, as opposed to the approach the SIP took to have namespaces for multiple priority sets that we felt just added complication without a lot of value. So that's the proposal as in the current draft. Next slide. The AVP is inserted by the sender of the request, usually clients, but it would not have to be. It could requests generated by a server back to the client presumably would need this capability as well. It can be used by agents for making throttling decisions. Presumably you would have a queue of something like a queue of messages at each priority and decide on routing of those requests or throttling of those requests based on that queue, the queue that the request sits in. It could also be used by the target of the request, by a server or a client for making resource decisions. You might receive an HSS taking a higher priority request and processing it before it would process a lower priority request. Next slide. Presumably applications would set parameters around when to use priority 0, priority 1, priority 2. The usage of the priority by agents and servers would be up to individual implementations, but probably with some text with guidelines around how you might want to use it. Applications could specify descriptive behavior, must level requirements on how to use the priority stuff. This draft presumably would not. Would leave that to applications, and then where applications don't specify a specific behavior, then it's implementation specific. Fairly obvious, you give a higher priority request, higher priority of getting successful or being successful. So next slide. Open questions. There are some security considerations. You could foresee the message priority being used to try to get higher preferential treatment for your client over somebody else's or over some other client. So if somebody comes in there and starts marking everything as priority 4, that kind of defeats the service or defeats the purpose of the whole mechanism. So I don't have an answer to how we handle that, but that's one consideration. There may be scenarios where it makes sense for agents to insert the priority. For instance, if you've got clients that do not yet support the capability and the agents can, you may well then have the agents inserted as a proxy for the clients. It has the same potential for abuse, and I don't know if there are scenarios here that says because of this potential for abuse, you want to sign the AVPs or make sure you really know who originated the AVP so you can act on it. You might act differently on a client inserted AVP versus an agent inserted AVP, possibly, I don't know. Again, just asking questions, not answering them here. And then application uses guidelines. Do we want to put in the draft suggestions on how, if applications are incorporating this, how they would do that, so that you don't have the GX application defining things in a slightly different way than the RX application and causing some kind of strange interactions between them. And the one case where I can see where this might be, where some guidelines might be put in there would be that last use case where we have within an application the same request type having different priorities. Well, maybe that differentiation would be using priorities 1 and 2. And if you're doing the emergency responder type priorities, you use priorities 3 and 4. Again, just thinking off the top of my head, that's the kind of guidelines that we might want to have, so that if you have an emergency responder scenario, all applications are setting it at 4, as opposed to some at 2 and some at 4.
Okay, so Martin Dolly, I'd equate this to the resource priority header that was defined and set for similar type services. And in there, with respect to security, it's based on the trust boundary. And so therefore, I as a carrier will trust the priority setting coming from ABC, but not XYZ. Okay, and so therefore, if I receive from XYZ, I will strip it. In addition, with respect to the values, the same concept, with RPH, where you have a default value, when you don't know the actual priority of that communication per se, but it's priority communication, would be left up to local policy. And so we don't really need to get into details with that up here, I think.
Yeah, and I was never suggesting any must level wording here, but maybe some guidelines. Again, the concern is that the S6A application team might take on a different philosophy than the PCC application team, and it could well be that for the same scenario, emergency responder being the case, PCC guys define priority 2 as being the case in the SXA to define priority 4, and it just doesn't mix well together.
Okay, so Martin Dolly. Yes, that's true. And but okay, for instance, within AT&T, we've had this discussion because of the fact that we realize that there may be coexistence of mission critical, the responders, on the same frequency band and within the same, core network as the government priority. And so each carrier is going to create guidelines. In the U.S., we have a guidelines document, being defined within ATIS, which is the standards for North America. And so other nations, because with respect to both those topics, public safety and government priority services that would be making use of this, it's really a national issue. There's not really a rule per se that's going to be one size fits all globally.
So it's probably the next suggestion that application specify it as a configuration, local configuration, on how they set it. Yeah.
Jean-Jacques Trottin. Yes, it's about the between applications. Effectively, it's how to ensure an homogeneity of the use of the service priorities, not to favor one application against another. I do think that it's an operator local policy so that it can configure the priorities in the different applications. So he has this way to do it. I don't know. But nevertheless, this question of homogeneity is a bit there. And also, it's also between operators. So if you receive a priority from an external network, when it comes in your network, perhaps you have to map in the diameter edge the priorities from external priorities to your own priorities in the network. So I think there is also this, but that is we're coming back to some implementation aspects. Another remark, it's about the number of levels, because the priority concept, it's not the first time there are priority levels defined in many specifications. And you have chosen 5. I am not an alternative, but perhaps we have to recheck about what is used in other places to see if this number is rather consistent. This is enough, not too big. And the other question, but I don't think there is a solution. What is the higher priority? Is it the priority 0 or it is the other one? Because, for example, in CX, in 3GPP CX, the level 0 is the highest priority. So the reverse of your proposal. In any case, we will have always such conflicting choice between existing applications who are already implementing some priorities